Did you share your screen with me?
Go ahead. I think you can. I think it's already
Okay.
done.
Yep, I can. Um, all right, let me get this ready to go on the slideshow.
You know what? I just called it as a phone.
All right, everybody can see it?
Okay, and let me ask everyone, please, to mute themselves. And it's usually at the bottom of the screen on your left, and it says mute and stop video. And then if it's on your phone, it's kind of the same thing. So
Zoom, right?
Okay, we ready? All right, everyone, we're gonna talk about a few different things tonight so that you understand exactly how this technology works. We're gonna talk about a few different topics that'll put it all together. Phototherapy, what's that process like? We're gonna discuss the GHK copper peptide and what it does within our bodies and how we produce it. Obviously, we're going to spend the majority of our time on stem cells, and we're going to finish the evening with water because it ties right into how these all work together. So let's start with our phototherapy because that is the technology that they're using to administer this protocol. So light waves, all energy that comes off the sun comes in the form of wavelengths. We think of light in the visible light wavelength range, but as you can see, that's a very, very small portion of all of the wavelengths of energy that come off the sun. Tonight, we're going to actually be talking about this infrared section for the majority of the time, which we can't see, unfortunately. So one of the things that we're going to discuss is the process of refraction. Now, if we look at white light, if we put it through a prism, we can separate those wavelengths, which we then see as different colors. And over here, this chart gives you the different wavelengths that each of those colors are. But that is the process of refraction, separating the wavelengths out. And why is that important? We will show you. So if we go in to infrared image, our eyes are not capable of seeing an infrared. Nocturnal animals can see portions of infrared, even down to your dog. The dog sees small amounts of infrared, which enables him to run through the house in the dark and not run into things. But in an infrared image or a picture or a camera or night vision goggles, those kinds of things, that is designed to pick up the different wavelengths of infrared and put it in a picture format. And here's a person and all the different colors are actually different wavelengths coming off of them. Now, infrared is heat. So we recognize that as heat. And since we give off heat, we give off infrared wavelengths. And you can see, we're going to talk about this a little later, this section of our body, because our heart and our lungs and major blood vessels to the head and everything are congregated in this area. So we give off a tremendous amount of heat right in this chest and back area. So we've known for thousands of years that specific frequencies of light can cause changes within our bodies. When we go out in the sun, a specific wavelength of, in this case, ultraviolet light, takes cholesterol in our skin and transforms it into vitamin D. Other frequencies of UV light can cause the production of melanin in our skin, which is what tans us and then protects layers deeper in our skin from further damage, possibly from different wavelengths coming off the sun. So, you know, the skin is the largest organ in our body. We're used to other organs doing different things for us, but the skin actually produces a tremendous amount of chemicals that our other organs throughout the body utilize. And of course, it does that with light. So what LifeWave has done is patented a technology that is based on this specific type of science. So the GHK peptide, This is a peptide. Now, let me say peptides versus proteins. Amino acids, which are the building blocks of all the proteins that our body produces. The difference between a peptide and a protein is if you have 50 or more amino acids that are combined, you produce a protein. If it's less than 50, they refer to it as a peptide. So in this case, we're only combining 3 different amino acids, and most amino acids, as they are produced and produce either peptides or proteins, bond with a mineral, and they utilize that mineral to catalyze chemical reactions throughout our system. In this case, the GHK peptide bonds itself with copper. So one of the things that this peptide does for us, and you're going to see a litany of things that it does, but one of the things that it does is, unfortunately, as we age, we produce less and less of it. And that begins to fall off pretty quickly. We probably peak production at around 20 years old. And by the time we're 30 years old, we have lost about 60% of our body's production of this peptide. Now, another thing is the peptide is pH sensitive. So our bodies are designed to operate in a slightly alkaline environment, 7 being neutral, 7.3, 7.4 is where we should be. That is not always the case. We produce lots of acid in the metabolism of our food, and if we don't get rid of that acid, then we become more and more acidic. And as we do so, some of these peptides and proteins don't operate properly. So for it to work, it's a pH sensitive peptide, and it'll give you the importance of our pH balance. So if we look at some of the things that the benefits that this peptide does for us, because there's an enormous number of them. One of the things is it stimulates blood vessels and nerve outgrowth, protects the skin from UV harmful radiation. It attracts immune cells to areas that need them. And so the proliferation of immune cells are dependent on this peptide being available. So as we get older, we are more vulnerable to disease because our immune cells don't operate as well because they utilize this peptide, which is diminished so dramatically. Reduction of inflammation throughout our system, increase of hair growth and its thickness. And it can also help with just pain, anxiety, and even aggression. Aggression and anxieties come from chemical imbalances in our brain, and one of those reasons is the lack of this peptide. It's got great anti-aging and skin benefits that include improved elasticity, reduced photo damage, reduce fine lines and wrinkles, and the improving of the collagen matrix. Of course, collagen is one of the most prolific protein that our body produces, and it's involved in all connective tissue throughout our body. So everything's held together with collagen. And of course, our skin, which we can see as we lose collagen or the matrix of collagen is not as good as when we were younger, we end up with lines and wrinkles that were smooth at one time. And one of the reasons is because the peptide diminishes. It can improve the bone density, repair and rejuvenate nerve connectivity in our brain. And certainly as we all age, we know things upstairs start to slow down. If we can improve that connectivity and speed that process back up, our reaction times improve. And that is, again, all dependent on the production of this peptide. Another critically important thing is the up and down regulation of over 6,000 genes. And what happens in gene response is, if we take an example of people who have never been, I should say, allergic to shellfish. They've eaten crabs and shrimp and everything their whole life. And then one day they wake up or they eat some and they end up with an allergic reaction. Why the difference? Well, there's a gene that was keeping that inflammatory response from happening from something in the shellfish that has now either switched itself on or off, and it is now allowing that inflammation to happen. And so we end up with an allergic reaction to shellfish. This particular peptide helps regulate those genes. And we've actually had people who have become allergic to foods that they've loved and can't eat them any longer. And after using this technology, have been able to revert back to eating them because the genes have remodulated back to where they were. The repair of lung tissue in people with COPD, DNA repair, and of course, free radical damage. We damage DNA all the time. Nerve regeneration, very important, and anti-cancer effects. And probably one of the other main benefits comes from the stimulation of the proliferation of exosomes that are produced by stem cells. And we're going to talk about how that is responsible for our stem cell activity. So all of these things are involved with this peptide that unfortunately, very quickly in our life, we stop producing at higher levels. So now let's get into stem cells themselves and what they do, how they repair our body, and what we can do to assist them in doing their job. So one of the things we want to talk about is the fact that stem cell research has been the most researched subject in all of medicine since they started researching medicine. Over the last 25 to 30 years, billions on top of billions of dollars have been spent in this research. And even today, you can go on to clinicaltrials.gov and see thousands and thousands of research projects that are going on with stem cells. Pick any major disease, whether it be Parkinson's or ALS or rheumatoid arthritis, go down the list of all of these debilitating diseases. And the majority of the research that's being done to help find cures is all being done in stem cell research. And of course, we've heard about celebrity people, Peyton Manning probably being one of the more prominent ones. Peyton broke his neck playing football. They certainly didn't expect him to play ball again, but they weren't sure that Peyton was going to regain full lower body functions. He ended up going to Germany because that stem cell therapy that he participated in was not available and is still not available here in the US, and we'll discuss why. But he went to Germany and had that treatment and not only regenerated all the nerves in the neck and spine, that he was able to be fully functional again and went back and played a number of years of football. So the unfortunate part of is, number one, those therapies aren't available here in the US. And number two, they are extraordinarily expensive. I think his ran about $125,000. So it's not available to the average person. All of the therapies and successes in the world are great, but if they're not available to you, then it really doesn't do you individually any good. So hence, we're going to look at another thing. So let's look at some of the new revolutions of what's happening in the process of stem cell therapies. Of course, our stem cells repair and rejuvenate tissue. So all of us would like to look, feel, and live like we did when we were younger, when we were repairing things as we damaged them. And stem cells are the key to that. They're a vital part of our immune system and the repair and regeneration of damaged tissue. Of course, immune systems have certainly been in the news over and on everybody's mind over the last year and a half with this virus. And we have seen stem cell therapy improve the regeneration of damage done by this virus. You've heard of some people with long-term slow progression of regaining taste and different functions that they've lost. Well, stem cell therapies have improved that and speeded that up. So let's discuss a few fundamentals of stem cells. Number one, they're capable of dividing and renewing themselves for long periods of time. And when we talk about long periods of time, we're talking about if we could live 120, 140 years, they're capable of regenerating themselves for that entire period of time. So for our entire useful life, they are an unspecialized cell. What I mean by that is they're not a bone cell or a liver cell. They are a stem cell. And those stem cells are capable of specializing to specific cells. And that is exactly how we repair damaged tissue is. Our body sends stem cells to either repair a damaged cell or replace it with itself and turn itself into whatever cell it was. So if it was a bone cell, and that's how bones heal if we break them. We put them back together and set, but what fills in the gap and bonds them together? Stem cells turning themselves from a stem cell into a bone cell and bonding those bones together. So that's how that process works. But the process begins in their ability to communicate with each other. And that process is done with exosomes. So we'll discuss what exosomes are. Exosomes are cellular materials. They're RNA messengers. And unfortunately, they decline, or the stem cell's ability to produce exosome declines proportional to the amount of the GHK peptide that we have in our system, because they require that peptide in order to do their work. So if we've lost by the age of 30, 60% of that production of peptide, well, we've lost 60% of production or effectiveness of our stem cells. And if we look at studies, by the time we're 60, we've lost 90 to 95%. And people at 70 years old or older almost have no stem cell activity at all. So as they're damaging things, as tissue, it wears out, it's not being replaced. So people, as they get older, see a degradation of their health in a more rapid rate. Whereas the 20-year-old, he can hurt himself, he can damage tissue, he can go out on a drinking binge and kill a whole bunch of brain cells. And in the next few days, they're all replaced and going strong. And, they're no worse for the wear. As we get older, we start paying the price. And it's because our stem cells can no longer create exosomes, which are the communication process of telling these things what to do. And that's because they need this peptide in order to do it. So if we hurt ourselves, let's say we break our leg, the damaged tissue gives off a chemical signal, and that chemical signal is received by a mother stem cell in order to create exosomes, which are the RNA packet of information that they then give off until it basically programs the worker stem cells on what to go repair. So if we look at what we'll refer to as a mother stem cell, it has all of these hair follicles around it, and those chemical signal. And in doing so, they then can create an exosome with very specific programming that they then extrude. So if this is our mother stem cell, they receive that damage signal, they create exosomes, which we're looking at all of these little round modules, and they extrude them into the bloodstream. The worker stem cell receives them, it then programs them. They can then follow that chemical signal back down to the damaged tissue, the breadcrumb trail that leads them right to whatever's injured, and then they can repair or replace the damaged tissue. And they use the GHK peptide to do that process. So years ago, there were certain things that if you damaged or injured would never regenerate itself. For instance, the cartilage in knees, very low blood supply area. And if you wore out or tore cartilage, they ended up removing it. And the only way to fix that problem was to get a knee replacement, because the regeneration of cartilage was virtually impossible, or at least they thought that in older people. And it's because the stem cells, which is the only thing that could rebuild that, weren't available. Now they are, with different stem cell therapies, including rebuilding tissue in lungs, reconnecting nerve endings. So there's lots of things that those stem cells can turn themselves into and fix. Here's a picture of the green line is nerves, and there's been some damage, and you can see these hot spots along the nerve or inflammatory areas that the nerve has been injured. And it is now recruiting all of these little red dots, which are stem cells, to the area to take care of that problem. So let's look at some actual pictures of what stem cell therapy has been able to accomplish. Now, I purposely picked an old study way back from 2002 where stem cell therapies were in their infancy. And these are some of the early things. And this is the kind of way back then, the improvement over time has been remarkable. So this person has neuropathy. Neuropathy can be caused from a number of things. An injury, and very possibly an injury in this case, because this person's missing a whole toe, or diabetes causes neuropathy, nerve ending damage in tissue. And then of course, the nerves control blood flow. And if we don't get proper nerve response, we lose blood flow to the area, and you've got diabetic ulcers and different things that can happen. So in this case, the before implantation of the stem cells, you can see some nerve activity and blood flow in the left foot, but the right foot, very, very, very little. With just 14 days of stem cell therapy, improvement in the blood flow in the left foot, but a tremendous improvement in the right foot that was almost non-existent before. So we're basically regrowing blood flow channels, reconnecting nerves, and bringing life back to an organ or a limb that in this case was damaged. If we look at blood vessels, in this case, we're looking at a blockage. Right here is the blockage of this artery. So blood flow down line is restricted. And of course, if it completely closes off, you would kill that tissue. With stem cell therapy, not only has you've gotten so much more lateral growth where we've grown new blood vessels to supply the area that, and especially in this, they're supplying this whole lower area with this trunk rather than here, which was blocked off. So again, within 24, we've regrown all of those or grew additional vessels that improve blood flow to that particular region. And here's yet another example of the same thing where we've just massively increased the amount of blood flow to the area. COPD, what actually is that? Well, if we look at a healthy lung, we have the bronchial, where the air comes down our throat into the bronchial tubes. And in the lungs themselves are all of these little packets of alveoli. And those are the little sacs filled with blood vessels that exchange gases within our lungs. They give off carbon dioxide that's been collected, it puts it into the lungs and absorbs oxygen. And that constant exchange of gases is how we bring oxygen in and expel the waste, which is the carbon dioxide. Now, in a person with COPD, bronchitis, different issues, where you have inflammation in the bronchial, it becomes restricted. So you right off the bat, you have a much smaller space for that airflow to happen. And then anytime we inflame an area, certainly in our lungs, the response is to produce mucus. And as we produce that mucus, it further clogs the airway, restricting airflow to the alveoli sacs. In this case, COPD is where those sacs have died completely off, whether it be from smoking or inhaling other chemicals, whatever the cause, we've killed off those sacs so they no longer are operational and exchanging gases. As that happens more and more in a person's lungs, obviously they can breathe and exchange gas. Happening to people long term is no matter if you give them pure oxygen or whatever else, without this proper tissue to make the exchange of gases, they don't. And they end up depriving organs of oxygen, and then they ultimately die of organ failure. They've just starved off the organs from the oxygen. And that's all things, their brain, their liver, all of the different functions. So here's some x-rays that we're going to look at of a set of lungs that have been damaged, COPD. So if we look at this pair of lungs, this solid black tissue is the way the whole thing ought to look. Everything that's got this either gray or white marbled area all through here is scar tissue and dead tissue. That is the damaged tissue in that lung. And with stem cell therapy, here's that same set of lungs where the stem cells have been able to go in and rejuvenate and replace all of this damaged tissue. And months later, we now have that same pair of lungs, full visual, which is the good tissue. And this person now has the ability to breathe and exchange gases in their lungs like they should, instead of these horribly scarred and limited. This is the kind of things that stem cell therapy can do. So when we talk about COPD, I had no idea that the number of people with this problem, well over 12 million, with another 15 million undiagnosed, because unfortunately, until the damage is done, we don't realize it. You know, as we get older, we do less things that maybe require heavy breathing. Younger, we may play a lot of sports, we may go out jogging, whatever. As we get older and we do less of that, whether it be just because of our change in our lifestyle, our work environment, whatever, we don't notice that our ability are diminishing until it's almost too late, until we realize, oh, I got a big problem. And then you end up with issues. So the beauty of stem cell therapy, if it was available to use before we had the problem, is we can proactively repair tissue as it's being damaged, rather than wait for a tremendous amount of it to be damaged and then have to try to start replacing it. So a proactive approach would be the logical thing here.
Wow, Carol.
The news is that we now know that stem cells can heal damaged lung tissue. They can grow new blood vessels. They can repair nerve endings and nerve connectivity. And we've seen that in the pictures that I just showed you. And like I said, the technology has improved dramatically since some of those pictures. Rheumatoid arthritis, back to the modulation of genes. As we get older, without that peptide, genes don't express themselves the same way. And in some cases, in the case of rheumatoid arthritis, when those genes either switch off, they now have there is an inflammatory response happening in joints, and our body either is laying down arthritis, whatever's causing the inflammation. If it happens for long periods of time, sometimes our immune system actually sees that as a foreign entity and begins to attack it. And that's where we come in with rheumatoid arthritis. We're actually, this is just one of the autoimmune diseases where our own immune system starts attacking areas of our body. We see that in, what am I thinking? Inflamed colons, where you end up with diverticulitis or whatever. You start destroying tissue, and eventually the tissue putrefies and becomes a foreign element. Our immune system attacks it, and you end up with Crohn's disease, another autoimmune disease that stem cells, or in particular, this GHK copper peptide, can help remodulate the gene back to where it was and stop the response that it's having at this point. So, as we talked about in the beginning, all of this is great if it's available. So if we look at where 99% of the studies have gone, it has been done in commercially produced exosomes. So how do they do that? Well, they'll take primarily from umbilical cords, because they're readily available, constantly renewed source. They are adult stem cells that are extremely active, and they're active even though the mother stem cells prior to becoming pregnant may be diminishing, because as she ages, her peptide levels fall off, but the baby actually responds and sends stem cells to the mother, helping the mother actually repair tissue throughout her body during a pregnancy. But the point that I'm making is that the umbilical cord is filled with stem cells, and they're extraordinarily active. So they can take that, they can look at what stem cells are producing exosomes, basically cull out the mother stem cells. They then grow them in a lab environment, in a petri dish, multiply them into the millions, and then and what they basically do is they bathe them in a solution of the GHK peptide, forcing them to continue to produce more and more and more exosomes. And then they collect the exosomes, and that is what they're injecting into people's knees or wherever they're injecting it, into spines or whatever, to repair the damage. The problem that arises is it is a non-specific exosome. It is not programmed to repair the damage that is in your body. It hasn't received the signal from your body telling what the problem is, so that that exosome is then programmed specifically for that damage. So it's a random, non-specific exosome. Now you're injecting it right into the damaged area, so it can't help but bump into some problems, and it does work. Part of the problem is this process is very time consuming, months, as well as it's real expensive, upwards of $10,000 an injection. And in the case of a knee, it may require 2-3 injections to begin to repair that tissue. So the average person isn't going to spend $30,000, $40,000, $50,000, especially since it's not covered at all right now from insurance. So that's an out-of-pocket expense, and that leaves it off the table for the majority of people. So injections, like I said, all of the big companies who have been spending those billions researching this, everything has moved into the line of injecting exosomes. As we said, they're expensive. They're risky because since they're not specific to your body and your body didn't create them, it can see them as a foreign body, and your immune system can actually go in and kill them off. So that's where your controversy comes in. That's why the Food and Drug Administration has not approved so many of these stem cell therapies that are being done around the world, whether it be in Panama, Mexico, Germany, and a lot of areas of the world. They're not approved here, and it's because of some of this controversy. And some of them have actually caused problems. There are no guarantees, and that's the first thing somebody will tell you. If you're going to get stem cell injections, is that we're going to try this, but there's no guarantee it's going to work at all. And it's because they know there's a hard, fast 20% failure rate. And that failure rate comes with different people's immune system killing off the injectable exosomes that they're actually. This process still has a long way to go to be fully operational and functional, although they are using it in some cases. So here comes David Smith, a scientist who looks at the problem from a whole different way. And he says, all right, we know that our stem cells aren't active because the production of this copper peptide diminishes in our body, and our stem cells need and utilize that peptide to do their communication. So they looked, first of all, into, well, maybe what we can do is give people supplements of the peptide or injections of the peptide. And they tried that. The problem with that is because your stem cells don't use it. And so if you go to GNC and get GHK copper peptide, and you can, and you take them, they're just not going to do what you want them to do. And because they are not bioavailable to us, a lot of times we can build up excess amounts of it in our system. They can actually become toxic. So David said, well, okay, let's go another step. Why aren't we producing it? And through his studies, he realized what's happening. And he's found that there was a specific wavelength of infrared light that was responsible for stimulating the production of this peptide in our skin. So he had already done and is the leader in phototherapy. So phototherapy, and we're going to show you what his patch is like, is, I'm going to run through this. This is just some of the things we just talked about. other than I didn't say that he's got over 70 patents for his phototherapy technology that has been proven to work quite well, and leads that whole industry for sure. So the difference is he takes a patch that's about the size of a quarter. Inside that patch is an amino acid crystalline structure that is a natural plant-based amino acid that is sandwiched between, again, plant-based cellulose, so that it's not latex, it's not rubber, it's not stuff that people tend to have allergic reactions to. And it is sandwiched between there, clear, so nothing that's in the patch actually enters our skin. This is a non-transdermal patch. It's not like these nicotine patches that people put on that actually impart nicotine into their system. The only thing this does is it takes the infrared heat that our body's given off, those wavelengths of energy, and it refracts them. And that's why we talked about refraction, the separation of the wavelengths in the beginning. And as it separates them, they've discovered, after 25 years of searching the millions of different wavelengths within the infrared spectrum, and that once they found which wavelength, then they were able to create a crystalline structure that not only separated the wavelengths, but then reflected back into the skin the wavelength that stimulates the production of this peptide. So as we give off heat and we break that apart and reflect it back, our skin then starts producing very quickly, within 24 hours, an increased level of the copper, the GHK copper peptide in our system. And in doing so, as those levels grow and get back to the levels that we had when we were 20 years old, before that diminishment began, then our stem cells within a matter of a few days become extraordinarily active, because they're sitting there waiting for information to go do work, but it can't get it, and they become active again. So you basically reset your own stem cells. So now they can read chemical damages and go specifically design RNA programmed exosomes to repair that damage. And so what we've done is we've allowed our own body to heal itself by stimulating the production of this peptide. It's the reason it can happen so quickly, as we talked about peptide does. That list of things, anti-inflammatory, all of those things. And we see almost a doubling of the peptide within 24 hours. And in about 5 to 7 days, we then reach that saturation level in our bloodstream. And then the GHK peptide begins to bond at about 3 to 5 days with the copper peptide, and then the stem cells become active. But people see relief if they have certain pain. They see improvement in things because the peptide itself can do a lot of good, and that's being produced very quickly. So this is what our little thing looks like. Like I said, it's about the size of a quarter. It's got adhesive on one side, and you just stick it to your skin, and it reflects and does its job. This patch was released in 2019, January of 2019. It's an affordable breakthrough because instead of thousands of dollars for an injection, we can get 30 of these patches. We use one of a day. We wear them for 12 hours. We take them off and allow that skin to rest for 12 hours, because if we overmodulate it for too long of a time, it gets used to that wavelength and it stops producing the same. It's the same thing with the sun. If we were in the sun 24 hours a day, every day, our skins would become less absorbing of a lot of the beneficial rays coming off the sun. We go into a night cycle, and that back and forth is what allows the skin to redo what it needs to do the following day. So he was able to do what multi-billion-dollar companies and big pharma have not been able to do. It is patented. which means for the next 20 years, nobody else can duplicate this particular technology. And he got that patent in record time. If anybody's familiar with the patent process, it is not unusual for patents to take 5 years, 10 years to get, because the process is, number one, you have to show that your invention is unique and different than anything that's there. They're not going to give you a patent for somebody else's idea. It's got to be specific and unique. And then you have to prove that it does what you say it does. And in David's case, he said it reflects back into the skin, this wavelength of infrared that then stimulates the skin to produce the peptide. And once the peptide is increased, it then starts producing, allows the stem cells to start producing exosomes, and they can prove all of that in studies and blood serum samples of how all of this stuff proliferates. And he was able to show that. They then farm that out to a number of different research facilities. They have to duplicate that, and then it's done a second time. So it's multiple stages. He was able to get those patents, or that patent, in about 15 months, which was record time. So in March of 2020, he received his 20-year patent on this patch, the X39. So there is no competition for it. This is the only place you can get it, and thankfully it's been proven to work. So if you would like to look further into some of that, you can go to x39clinicalstudies.com, and there are over 100, I think, in there now, of all of the different clinical studies. There was a doctor that just completed a clinical study just a few weeks ago. That's being published right now, again, showing and proving that this technology does indeed exactly what it says it does. So athletes, now, let me go back a little bit. In the process to find what wavelength stimulated the production of the GHK peptide, along the way, he discovered a number of other wavelengths that did other things. There's a sleep patch called Silent Night that improves the production of melatonin in our system, improving the wake-sleep process. There's pain patches that will block signals to the brain, so an area that's receiving a lot of pain. There's an energy patch that assists the body in producing ADP. And this is some of the things these athletes are using. And they have been for years, because this was a 15-year-old company when the development of the X39 took place. And it was a successful company because of these other patches. And of course, we use those other patches in addition, but the X39 was the creme de la creme. It did what he was ultimately looking to do, which was stimulate stem cells. And there's the big rejuvenating process. So athletes have been using them for a long time. Matter of fact, some of our Olympic athletes, you could see wearing patches in our recent Olympics. So there's a number of them still doing that. Other benefits from both the peptide and we see from wearing the patch: improvement in sleep almost from the very first night. And we've had some doctors that I work with in our consulting company, our health consulting company, have a sleep study they have a sleep study. They treat people with sleep disorders, do tests on people to see what's causing some of their sleep problems. And consequently, first thing I did is I went to them and said, let's do some sleep studies with our patches. And one of the things they can show is how much restful sleep we get, how much unrestful sleep, or non-restful is the way they describe it, how much REM sleep, and different types of sleep that we go through. Now, if we fall asleep and sleep all night, we don't know how much of any of those different sleep patterns we've been through. If we're not in restful sleep for a sufficient amount of time, we don't repair our body, we don't get the rest we need, we'll wake up tired. And what they found is from a person that had, I think, 63% restful sleep, put the patch on in the morning, they wear it for 12 hours, remove it that night, their restful sleep went up into the upper 80s and low 90s. And we've repeated that over and over again. And over a series of nights, as the peptide continues to increase in our, we see even better sleep patterns that go even deeper. So you see people who are restless, they get up, they can't sleep all night, all of a sudden getting far better quality and time duration of their sleep. So that's another great benefit that's come about. Wrinkle reduction, because the improvement in the collagen matrix as we're producing, and collagen is what? It is a protein, the largest production protein of our body. Well, if it's got a better matrix that is tighter, more flexible, well, then we remove some of those wrinkles that are starting to happen as time goes on. But that's visible. What's happening in the arteries in our heart, those things, as that collagen is not as good, we end up with hardening of the artery, less flexibility in our arteries, and those things cause other problems. So those are the things we don't see as the collagen matrix begins to degrade over our life. So here's some examples of that. In this picture on the left, here's the lady before she started using the patches, and you can see wrinkles beginning in her neck, around her mouth, and certainly underneath the eyes and along her brow here. After using the patches for a few months, tremendous improvement here and here, certainly under the eyes, and look at the difference in the skin in the neck area. Here's a lady who began here, day one, and again, we've got creases forming around the mouth area, and after 30 days, look at the improvement. Now, it's not going to make you 18 again, but it's doing things. We didn't get there in a year. It's going to take time, but over time, it continues to improve. This is the one I think I like the best. Here's the lady on day one. And of course, we see her eyes beginning to have little pouches and sacs that happen along the nose and mouth. And one of the things I want you to look at is the eyelid itself. You know, this upper eyelid is no longer lifted as much. It begins to come down a little. Here's after 42 days, and we begin to see some improvement, certainly here. A little improvement here, I guess a decent amount, but look at the eyelid change. Instead of it folding over itself, it is now tightening up and allowing that eye to open even further. And you're getting a different look. And then here's after being on the patches for a year. Tremendous change in that eye. Look at the underneath eye compared to the beginning to a year later, and certainly all of the skin in her face. So those are some of the things that are showing you very clearly what this can do. Hair growth, this wasn't something they expected, but we find out that there are stem cell little pouches that hold stem cells at the hair follicles. And as we improve stem cell production and activity, then we start seeing the hair rejuvenate, and those hair follicles can be repaired and come back to life, begin to produce hair both thicker and in more proliferation. And here's some examples of that. Here's a gentleman before using it, and he's beginning to thin, and over time, he's thickened up quite a bit. Again, here, from here to here, and this is over a year. This gentleman, you can see the beginnings of the thinning and how much thicker the hair got over that period of time. So those are just some visuals of what happens. Scar reduction. Again, when scars are laid down, is matrix of the collagen that pulls and heals the skin together, and it's an inflammatory period. We've got damage and injury, so a lot of times the skin doesn't heal as nicely, and you end up with a large worm type scar. It could be raised, discolored, whatever. What we've seen is remodeling of that. We're constantly changing our skin every 14 to 16 weeks from the lower dermis all the way up. And myself, with some bad scars from the number of surgeries I've had on my feet, I had those big wormy scars because They've gone into them a number of times and just trimmed them and put them back together and put them back together. I had a big old thick line across there that was raised and slightly discolored. And in using these for a little over a year now, those scars or pencil line, you have to look for them. They're just a fine pencil line with no raised tissue. So total remodeling of that tissue. Now, in my feet, it really doesn't matter. Nobody sees that on it. But if it was a scar in somebody's face or something, when that kind of remodeling takes place, that becomes an important thing to their look. Certainly wound healing. The peptide itself, as we discussed early on, is improvement in wound healing, but stem cells can go to the rescue and repair and replace dead or damaged tissue in an area of a wound. And here's some examples. Here's a young man who was in a bad car accident and almost tore his hand off. He started using the patch, and here's where he put it, right close to where his injury was. And in 63 days, we went from this injury with nerve damage, tendon damage. They weren't sure he was going to have full utilization of his hand, to this. Now, we see where this wound is. So we can look and we can see there's some scars peeled in, but he got full utilization of the hand and in just healing. This is a little 9-year-old boy whose finger got smashed in a door and it clipped the tip of his finger off. They were able to sew it back on, but because of the lack of blood flow early on, that tissue became black. It was not getting proper blood. As we talked about, the stem cell therapy can improve regeneration of vascular in the area. And so here's just 3 months later, the healing of that finger. You can hardly see where the scar is. He got feeling back in the tip of the finger, and he didn't lose it even to the point where the nail's regrowing. So that's the kind of things that the X39 is proving that it can do. We talk about youth renewal just because of the improvement in repair and the remodulation of genes. That's another critically important thing. The repair of DNA, bringing it back to its youthful state that it is deteriorated from. So the global expansion of the stem cell markets. Once you come up with something that is this readily available, and it is now being sold worldwide, we're seeing people buy into this and use this in record numbers and growing dramatically. In 2018, we talked about the company before they released the stem cell therapy patch, the X39. They were selling their other patches, which were doing quite well. They had a revenue in 2018 of over of $20 million that year. They also are a debt-free company. So it is privately owned by David Smith. It is debt-free, and it is growing, and he's got the capital to continue that growth process. In 2019, after the release of the X39, they went from 20 million in 18 to over 70 million. This was what they were expecting in 2020, 220 million. I've heard that it exceeded 250 million, and they're on schedule to go and be $1 billion company in less than 3 to 5 years. That's how quickly this is expanding worldwide. And those of us who have shared this, as we're doing with some of the new ones here tonight, we see the growth in our business because more and more and more people are jumping aboard, not only to use the patches themselves, but with the results they're getting, they cannot help but go tell somebody, and they're helping us spread the word with, again, signing up and getting a distributorship, which allows them to then sell them to people. So we are certainly changing lives with this therapy. So water. One of the things we need to talk about with water is, without sunlight and water, life doesn't exist. We need the energy from the sun. There's our phototherapy process. Standing in the... We also need water because water is the solvent that all of our biochemical reactions take place in. Dehydration is a big problem. with only a 3% dehydration of a cell, the cell loses 10% of its ability to do work. We don't get thirsty until we're 10% dehydrated, which means by that point, cells throughout our body have already lost 30% of their functional ability. So to add to that problem is the process of purifying water, and certainly that is a necessary process, changes the structure of the water from the way it exists naturally in nature. So if that purification process produces a structure of the water that our body's not capable of utilizing properly. So we can drink it, but how much of it actually gets absorbed into our cells? Maybe 15 to 17% over a 3 to 4 hour period of time. Since the average person requires about 65 ounces of water throughout a day to stay hydrated and for their cells to work efficiently, if they drank a gallon of this tap water, bottled water, whatever, this restructured water that purification causes, and they only absorb 15%, they're only getting less than 30 ounces. That's less than half of what they need in a day. So they can be drinking copious quantities of water. And trust me, a gallon of water is a lot of water to consume in a day and still be chronically dehydrated. So what's the problem? Well, every cell in our body, whether, if we're working, if an athlete's working, we see that decline in function over a few hour period as they begin to dehydrate. They don't perform as well at the end of the game as they do in the very beginning. But what about our heart? It's not beating as well because every cell in it is not operating as it should. Our liver, our kidneys, all of those purification processes, the production of energy within our other cells, all of those things drop off dramatically. And guess what? Stem cells or cells, they require water to work. And if they're dehydrated, they don't work at their efficiency. So here we are using the patches to increase the production of our peptide, to improve stem cell activity. And if we're dehydrated, we then take the stem cell and we put the brakes on it. We tie two hands behind its back. So it's critically important to hydrate properly. And since the copper peptide is also pH sensitive, as we become more acidic, then we can have our blood saturation levels, the capacity for it to saturate becomes lower and lower and lower. So even at what's then saturation level, we're way down from where we should be, and we lose productivity there also. So there's a combination of problems. So let's talk about cells and how water enters them and the structure of water and how that works. So the process of electrolyzed reduced water. So that happens natural in nature all over. There are wells that come out of the ground that have been identified all over the world. One of probably the most prevalent that people know about would be the miracle waters of Lourdes, France. There's actually a spring that comes out of the ground that has electrolyzed reduced water. It has negative charges of about 130 or 140. And it's been used since biblical time of the healing waters. And it can help your body heal itself. Plants use the sun, its energy, and through the photosynthesis process, take the water that has been brought up into the plant, and it electrically, because just like a solar cell on your roof, it takes energy from the sun and converts it to electricity. It's the production of electrons. And then the plant actually breaks this water apart. It restructures it into a state that if we eat the plant, our bodies are designed to operate on that structure of water. And so if we eat watermelon that's full of water, it is full of electrolyzed reduced. A machine like the one that I'm going to show you tonight, but it's being done by the machine of the plant, the chlorophyll of the plant, and it is doing the same thing. The spring in Lourdes, France happens because of different magnetic fields underneath the earth that as the water percolates up through it, it begins to reassociate that water. So how does it happen? As we inject electrons into the process, if we take our water molecule, oxygen with 2 hydrogens, we basically tear off one of these hydrogen atoms. And we're splitting that water into 2 flow processes. It happens in the plant through respiration. The acidic aspect of the water gets vented out of the plant through their bottom of the leaf through the stomata, and the other water stays inside the plant that it can use, and if we eat the plant, we can get. So H1, 1 hydrogen atom, is extremely positively charged, which means it's missing electrons. It will, and the increased amount of H1 in a solution increases the acidity level of that solution. So the more H1 we have in solution, the lower the pH, the higher the acidity level. So if we tear off one of those and take that water, the rest of the water, and migrate it to this side, what do we have? We have, sometimes we'll tear both of them off and we end up with H2. Is very different than H1. H1 is positively charged, H2 is a negatively charged ion. This is a strong, strong antioxidant. We have oxygens that are negatively charged because all of its electron fields have been filled. And then we have this little guy called a hydroxyl ion, which is an OH, negative charged hydroxyl ion. So how do these things work in allowing our cells to utilize water? So let's look at the cell and how it builds up acid. If we have positively charged water, which means these atoms and molecules are missing electrons, so they are positively charged, they're trying to share some of that electron charge from the atom next to it, and they begin to cluster in large clusters of 16 to 32 molecules. If we look at our cell, the interior of our cell is negatively charged, which it is necessary to be because our brain signals are what? An electron exchange. So all of the information going to the cell happens through an electron flow, and that happens in a negative environment. The exterior of our cells are positively charged, which the cell should be in balance then. The membrane that allows water into a cell, which is referred to as an aquaporin, is very, very positively charged. It's nature's way of stopping positively charged fluids from entering the cell because they are oxidizing. They do damage. They do free radical damage. So there's 2 reasons that this water doesn't want to enter this cell. Number one, it's positively charged and the cell is positively charged. So it's like trying to shove the positive ends of 2 magnets together. They repel each other. And then on top of that, it's a large cluster that in most cases gets larger than the hole. So it's very difficult to shove a basketball into a baseball size hole. So again, another problem with that water getting in. Consequently, we fill the connective tissue outside the cell with this positively charged water, and very, very little of it actually enters the cell. The only reason any of it enters the cell is because as you engorge this tissue and our hearts beat and we put pressure, we actually jam some of it. We ram some of it into the cell, and that's how you get that 15 or so %. Now, as we metabolize food, burn food as a fuel, one of the waste products, the ash per se, after we burn the fuel, is positively charged hydrogen atoms. That's our waste. So what happens? Since the negative charge on the inside the cell, and that's a positively charged ion, it sticks to the wall of the cell, doing 2 things. First of all, it stays there because it's stuck. So as fluid goes in and out of the cell, it doesn't take it with it. As we increase the number of positively charged hydrogen atoms, that cell's going to go acidic. As it goes acidic, acidic solutions repel oxygen, so they absorb. That solution is then has less of an ability to maintain positive oxygen amounts. And so now we're trying to burn fuel without the proper amount of oxygen. And if we go to our gas stove, if we turn on the flame and we get the right mixture of air and gas, we have a nice, tight, hot, burning, bluish white flame that gives off very little waste product. We can put a pot on it and it doesn't soot the pot up. But if I take the oxygen away, if I retard its air, then the flame gets very large and meandering and yellow. It's not burning near as hot, very inefficient burn. It's giving off a massive amount of waste. If we put a pot on the top of that flame, it'll soot the bottom of the pot up instantly. So the soot is nothing but more positively charged hydrogen atoms. So we're continually exacerbating the problem. But there's one other issue. As these things stick to that wall, it neutralizes the charge on the wall, and eventually this cell will no longer be negatively charged on the inside. And when it stops being negatively charged, it cannot receive brain signals. No electrons can flow through it. So if it's a heart cell, it stops beating. You end up with congestive heart failure, low heart rates. And it's because the cell is highly acidic, and this is the reason that it happens over time. So how do we remove that? Reduce water, or if we're eating foods that are full of water, plants, green vegetables and fruits, which are full of what? Electrolyzed reduced water, then we don't have these big, large clusters of atoms. We have individual ions, because all of these ions have their electron fields filled. So now they're all negatively charged. So they're going to repel from each other. Instead of being clustered together, they're all individual. So now I'm trying to put a BB into that baseball size hole. It'll fit. And they're negatively charged, and the cell wall and the membrane are positively charged. So they get drawn to it and pulled into the cell. This is the reason that this kind of water rapidly hydrates. Instead of 15% over 3 hours, we can get 98% in 3 to 5 minutes. And as it goes into the cell, it's bringing a handful of things. It's bringing great negatively charged oxygen. It's bringing some of these hydroxyl ions. Of course, there's some water molecules also. And when these hydroxyl ions get inside the cell, their negative charge is stronger than the wall negative charge. So they can actually pluck these hydrogens back off the cell wall, making a water molecule, so that when the water leaves the cell, it takes all of this. This is how we get rid of acid waste. This is how we get rid of the burden that is on our buffering system that's overwhelmed because it cannot reduce this acid. And we end up getting a cell back to its natural pH. As the pH modulates to its proper point, then our copper peptide can reach a much higher level of saturation. And the cells are all hydrated. So now they're working at their full efficiency instead of at a third or a half their efficiency. So we have also seen people who are drinking electrolyzed reduced water see a tremendous amount of much quicker and better results, and for the reasons we just got finished explaining, of the stem cell therapy, the X39s, than people who are drinking bottled water or tap water because of the problems we just discussed. So if you're not already drinking this type of water, and there's only one machine that's created in the world that does it, there's a lot of knockoff models that try to tell you they do, but they don't, and it's easily proven. But if you're drinking this water, then you'll see great results from the X39. If you're not drinking this water, whoever invited you to this call, talk to them, because you need to look into this also. By itself, the health benefits are tremendous. In addition to, if you use the stem cell patches, you'll get a far better result. So that's the process by which we can activate stem cells and improve the quality of our life, the quality of the healing. And that's the end of my presentation tonight. So I'll open it up to some questions. I've got about another 10 or 15 minutes before I've got another call to be on. So anybody have any questions, I'm more than happy to answer them.
Glenn, that was really excellent. And every time I listen to it, your message isn't different, but I guess I'm different, so I hear it in a whole new way. And one thing that you talked about was the GHK, how -CU, how it I wrote it down. It can remodulate the gene and stop and reverse the damages. And so that was really interesting when I saw the pictures of, the beauty pictures of the reversal of the wrinkles. And I never noticed before that lady who had this saggy top eyelid.
Yeah.
That was so amazing that I never, as many times as I've seen that picture, I didn't see that. And so you said that every 16 weeks our skin is regenerated and remodeled
14
from
to
the,
16 weeks. Yeah.
can you tell,
Well, you're producing new skin way down deep in the dermis that then works itself to the surface. It
yes,
takes about 12 to 14 weeks to get to the surface. So the better quality of the matrix that's producing the new skin deep in the dermis, the better the quality when it reaches the surface. And in the case of her eyes, just like this, the skin sags on our face because it's not as tight, then so do our eyelids sag and they're not as tight. So you end up closing them a little bit. But this is the same thing that's happening inside of our arteries, that they're not as flexible. The skin isn't, or the artery isn't stretching. So instead of when our heart beats, the ability of that artery to open up and absorb some of that pressure, it just blows it through like putting it through a nozzle of a hose, and it gives back pressure. That back pressure causes increase in blood pressure, and it causes strain on the heart that's trying to drive against that pressure. It takes that load off. Those things
fascinating.
improve, and as the collagen within the artery improves, it becomes flexible again. It begins to thin instead of being such a thick, heavy wall. As it gets flexible, you get improvements in all of those things. Less wear and tear and strain on the heart, and less damage to the interior of the arteries that could eventually begin building plaque and cause blockages. So those are all things that the reason we don't see those blockages in 20-year-olds, unless they're doing really crazy things, drinking um, Red Bull and those kinds of things, they can do damage to themselves. But the reason we typically see these kinds of things happening to people later in their life
Hmm.
is because we're not repairing, and we've lost some of that flexibility, and things are beginning to wear out and tire, whereas we can repair them. And I know I took a test that measured my arterial age, which is actually measuring the flexibility and the thickness of the walls of the artery. And the first test that I took was very close to my age. I was 65 at the time I took it, and it showed I think it was 63, 64. So I was right about, matter of fact, they said that's great because typically it's a few years older. But then after 90 days of being on the patches last year, we repeated that test, and it reduced my arterial age down to 46. And
Wow.
if when I started looking at those diagrams of the arteries, they had the thickness of the wall had shrunken dramatically, and the few little spots that had, thankfully there was only like 1% plaque on a few little spots, that had all gone away, and the arteries were moving every time the heart beat. So I was getting flexibility back. I didn't have high blood pressure problems, but it did lower it a little bit. It was always in range. So those things were, they're very seeable. I mean, you can just take tests to look at what's happening inside of your body. And we take the load off the heart because now it's not pushing against a wall every time it tries to beat.
It's really fascinating, all of it. I just love it so much to see how we can all, not just me or you, but anyone who puts these patches on will see a reversal in the aging process. Are there
Oh,
any
and I
other
think
questions?
expectations got to be right. I mean, we didn't get
That's
there
true.
in a week. It's not going to all just, we don't put the patch on and 30 days later, we're 18 again. It doesn't work that way, unfortunately, but it is repairing, and we can quantify that repair through not only tests, but x-rays and all kinds of things, as you saw. And so people do see increases in energy. They do see their ability to do things that they had stopped being able to do because of arthritis pain, or just aches and pains that didn't give them the flexibility, and all of those things. I've been on them a year and 3 or 4 months now, and all of those things have improved dramatically.
I have a question related to that, Glenn, if you'll permit. Briefly, because I know that one of the side benefits, I guess I'll call it, from stimulating your stem cells, and actually it's the GHK copper, the copper tripeptide, is we also get some benefit in enhancing the glutathione in our bodies.
Correct.
And so the glutathione is a tripeptide itself.
Mhm.
And what are some of the benefits of enhancing glutathione in your body? Can you explain
glu-
some of that?
Yeah, glutathione is the body's natural antioxidant. And if we look at glutathione compared to other antioxidants that we might consume in foods and all, it is the king of antioxidants, and we actually produce it ourselves. But it too diminishes, and this patch will improve dramatically the amount of glutathione that we produce. And glutathione, you will see, for instance, in the heart is a good example. The valves in our heart get worked to death, right? Think of how many times they're opening and closing and opening and closing. And every time they close, they're getting mashed from the other side because of the pressure of the next beat of the other chamber of the heart. So they take a beating. And over time, they begin to thicken as a response back to our collagen production. Glutathione works very much in helping that stay flexible and not wear out, so that you don't wear out valves and improve. And then certainly in our brain, our cognitive abilities and the speed at which neurons flow through our tissue in our brain, it requires these antioxidants, or you start getting oxidation. That process is very strong in our cognitive abilities. And
What about
so,
what about lubricity of joints? And you mentioned rheumatoid arthritis, which is the one that kind of curls people's joints up. What about osteoarthritis, like people get when they're athletes and their joints
yes,
just kind of dry
well,
out
here's what
wear
happens
out, right?
with osteoarthritis. There's a process as our bodies become acidic. We start overwhelming our buffering system. We cannot make enough buffers to buffer everything. Now, nature runs its course, and there are priorities. Our first priority is buffering our blood. Our blood has to be at 7.365.
Right.
If it gets off just a few thousandths of a point in either direction, we'll actually die. So you're going to buffer your blood over and above everything and anything else. But even then, we may not have enough buffers. So there's a backup system, and that backup system is releasing a chemical that dissolves our own bones to extract calcium from those bones to assist in the production of buffers. Now, there's a problem, because when we look at minerals in general, there are minerals in different formats. There's what's called an elemental mineral, and that is minerals that are bound together in large clusters of molecules. They're just like we were talking about clusters of water, similar type thing. And then there is an ionic mineral. So when the plant takes up minerals, they're elemental. Through that photosynthesis process, it is not only ionizing, breaking up the water molecules, it is also ionizing all of the minerals it's absorbed. So all the calcium that might be in spinach that came into the plant as an elemental mineral gets ionized into an ionic atom by atom of that particular thing, not clusters of molecules. That is the way our bodies are designed to absorb minerals. We can absorb and utilize about 98% of an ionic mineral, and we can get rid of anything we don't use. And in the form of calcium, if we take elemental calcium, supplements, whatever else, or if we drink in tap water, it's full of calcium, but it's in an elemental format, our body can only use maybe about 6% of that, and it has a big time problem getting rid of the balance.
Right.
It has no way to excrete it back out the body, so it precipitates it into joints. That's arthritis that begins to build up. It can actually precipitate into stones as our body becomes more acidic. It'll actually form stones rapidly in organs, kidneys, livers, pancreas, all kinds of places. So with osteoarthritis, you're dissolving your own bones, which are elemental. We use a little bit of it to stop our blood from getting out of whack and killing us, but the rest of it ends up getting dumped into our joints. So that's where the osteoarthritis comes from. If
Gotcha.
you go back to drinking the water, you're getting proper calcium. You can recalcify the bones. You can get rid of the acid waste so you're not burdening the buffering system. Then it has enough buffers to do everything it needs. It never dissolves our own bone, which is why we see an improvement in bone density with proper water in its right structure.
Thank you. I understood that. Thank you very much. Appreciate that very much, Glenn. That's great insight.
Anything else? I've got about another 2 minutes and then I've got to run.
Yes.
Martha?
Yes.
Jeff, you
Go
have a
ahead.
question?
Yes, first of all, excellent presentation. I was tapping away many notes, and I know I missed quite a lot, but I think I got the essence of it. And the beauty of the patches, as you pointed out, is that it seems as though rather than worrying about having a specific fix for a specific problem, when you get the body working properly, then it's allowing communication of various parts of the body that need repair, and then that repair can unfold.
That's true. And it's a systemic situation. You're filling the bloodstream with the chemicals it needs to do what it needs to do. We're all recording this, so I'll be able to send you a copy of this tomorrow if you want to look through it a second time. You know, you always pick up more things after you see it another time.
Right.
Sounds good. We appreciate it. Thank you so much.
Okay. Oh, by the way, everybody, Martha and Jeff just got their Enagic Kangen machine and we installed it earlier today. So they've been drinking water from the store, but they now have their own, and
Yay.
very happy for them.
Thanks so much.
Expertly we're going to characterize it.
There you go. Well,
Thanks so much.
Well, thanks everybody for the evening. Y'all are welcome to reach out to me individually if you have further questions, but I know I've got another call to be on in another minute, so I'm going to have to go. We'll see
Glenn, you
next
were
month. We do this
spectacular.
presentation every month. I do this presentation every month. Desiree has this call every week and has other guest speakers that talk on different parts of the subject. So if you're welcome to tune into this, save the login, and it's the same one week in and week out, and you're welcome to join the call on a monthly basis.
Thanks a lot.
All right, guys.
Thank you,
Glenn.
Glenn.
Thank you
Everybody
much.
appreciated it.
All right.
It was excellent. Thank you.
Good night, all.
Good night, everybody. See
Good
y'all
night.
next week.
Bye.
Bye-bye.